Good afternoon, everyone. I'm Matteo Degiacomi. I'm the program director for the Masters in Data Science. And well, this is a small presentation to, first of all, think about what is data, what is a data scientist, where are data scientists needed, and then, of course, how does this map with the curriculum that we have planned in the Masters in Data Science. So just a few words about myself. I hold a joint position. I'm a computer scientist, so I hold a reader position in informatics, but I also hold a reader position in chemistry. So the reason is because, well, my research area is computational biophysics, so very much my job is using data science tools to make sense of the data that is produced in the physical sciences. So very much this master's fits very well with my own interest and area of expertise. Right, now, to get started, I would like to start thinking about what is data and what does a data scientist do. So a good place where to start would be, oopsie, there we go, right. So what is data? Well, data is inherently not very informative by itself. Data is unstructured. Data is just observations that have been made. The job of the data scientist is to make sense out of data. And the way data scientists make sense out of data can be, I think, well understood by looking at the IKW pyramid, which is what we will be discussing now. So the job of the data scientist is to take data and convert that into information. And eventually that information can be converted into knowledge and into wisdom. Now, in practice, what does that mean? Well, essentially, the idea is the following, that information is the identification of relationship between data. Knowledge is when one starts making a whole, seeing connections between all of the individual small connections we have seen, when a whole body of knowledge is gathered. And now this information gathering, this knowledge gathering, is based on past data, is based on historical data. Now, the job of the data scientist is truly critical because through the analysis of the past data, we can define the future. So in a company, that can be deciding where we should invest next. Into a research setting is what experiments we should be carrying out next. So as you can imagine, therefore, the data is truly the most important asset in an enterprise, because essentially that's what underpins, through data science processes, what's next the enterprise should do. So as a result, of course, it is crucial that data is efficiently, effectively, and reliably collected, stored, maintained, updated, processed, analyzed. Truly, data is the most important asset. So now, up to now, I've been talking about data very abstract, in a very abstract way, but of course, thinking about more concretely, where do we find data and where do we find data scientists to process this data? So to get a bit of information on that, there's a nice website, so 365 Data Science. So what the folks at 365 Data Science have done, that's for last year in 2024, they have scraped a few thousand job offers on online servers. And they have, first of all, asked the question, which sectors require data scientists? And what you can see from the pie charts represented here is that essentially data scientists are everywhere. Of course, in different concentration, but you can find data scientists from areas from technology and engineering to, like myself, in healthcare and life sciences, or in human resource and employment. So data per se is agnostic, is what you do with it that matters. And as you can see, every sector will benefit from data scientists. Now, if you think about the nature of the data itself, of course, different sectors will have different types of data. So one of the main sources of data, of course, are humans. So you can think about medical data, for instance. That's an example of human-gathered data, where this information could be, for instance, the treatment a patient has received, the kind of diseases the patient has been diagnosed. This is an example of human-gathered data. Voting, polls, those are examples of human-gathered data as well. But of course, more and more in the technological world, data starts being gathered automatically, and it starts being gathered automatically on physical machinery. If you think about telemetry of cars or industrial robots, or even more, and this is the primary cause of the data explosion we are witnessing at the moment, digital sources. So, of course, humankind every year is producing more and more data. And the primary responsible for that is digital data. You can think about statistics on traffic on servers, on the stock market. So this also, of course, this data explosion per se doesn't do anything useful unless we can make sense of this data through data science processes. Now, another thing we can ask ourselves is, okay, in what forms does data present itself? Now, data needs to be structured in some way for us to be able to gather information from it. So, of course, data can come in the form of relational databases, document stores, graph databases, key value stores. There's many different ways one can store data. And one of the key points for a data scientist is that, well, reflecting on what's the most efficient, what's the most effective, what's the most useful way to store data will then define what we can do with this data, what kind of information we can extract for it, or how easy it is to do that. So reflecting on how the data should be stored and how we can manipulate stored data is part of the skills a data scientist should have. Now, think about skills. What kind of skill does a data scientist need to have to manipulate all of these type of data sources from these many different industrial sectors, and data that is structured in many different ways? So going back again to the 365 data science analysis, what another question I would ask is, what are the programming languages that are most often sought after in job offers? And what you can see in this histogram is that Python is definitely nowadays but that was 2024, the language that is the most sought after, followed by R and SQL. So essentially Python, R, and SQL, let's say, do the lion's share in the toolkits of a data scientist. And now this observation, I think, is echoed by another statistic that has been gathered by Medium.com. So the folks at Medium.com tackled the question of finding out what the skills required are in a different way. So what they did, they interviewed the HR of a whole range of Fortune 500 companies. And they asked several questions. The two I found most interesting for the sake of this presentation are, what are the top tool and programming languages on one hand, and more specifically focusing on the skills for freshers, what would you like a fresher from the area of data science to know? And first interesting observation is that in both circumstances, again, we see the same results as 365 data sciences. Python and R are definitely the languages that should be known. Now, what I find very interesting, especially in the skills for freshers, is that the second most and third most sought after skills are soft skills. So problem solving and communication. So in particular, I would like to focus on communication because very often the role of the data scientist is to carry out, of course, processes that might not be immediately understandable per se by the final beneficiary of your analysis. The data scientist will have to interact, first of all, with people gathering data who are experts in their own sector. And so, of course, communicating with the experts of the sector is really critical. But of course, then through the whole analysis, the data scientist will eventually gather knowledge that will need to be presented to stakeholders. And those stakeholders might not really potentially understand much of programming at all, or of data science at all. So the skill of talking to people who are experts and not experts, so skill of communicating at different levels with different type of experts is really crucial for a data scientist. This is despite what one would think, it's not just a programming job, but it's very much also a kind of a people-oriented job. You should be able to interact with people to understand what the limitations of the data are and how to present your results in an effective way should be done. Now, final point I would like to make about skills. The data scientist is typically not a one-trick pony. Typically, you're not just an expert in Python, or you're just not an expert in SQL. The data scientist should be able to wield a different set of tools programming languages, mathematical models, and combine them in such a way that the question that needs to be addressed can be actually addressed. As an example, but typically, of course, you should be able to program in Python, but then you should be able to interact with cloud platforms. You should be able to, nowadays more and more, use machine learning methods to extract information, and this machine learning should be deployed, most likely, on remote servers. Those remote servers very often do not run on Windows or on Mac, they run on Linux. And so also knowing how to shell script, which is, of course, the language of communication with Linux, is important. So acquiring a variety of set of skills, both soft and hard, is truly important. And that, I would say, maps very well with what is taught in our masters in data science. So first of all, course brush. In terms of hard skills, definitely in these masters, there will be the opportunity of learning or either from scratch or improving your machine learning skills. Definitely, you'll be learning how to interact with the databases. And one of the important skills of a data scientist is that you need to have strong mathematical foundations in terms of probability and statistics. So these are all skills that you will be able to either polish if you have already, or acquire if you don't have them yet in the masters. And notice that we have also soft skill mentioned in this in these slides, because the ability of communicating, as I mentioned previously, is very important. And through the opportunities of applying data science techniques to different applications that might be very diverse in terms of sources of data, in terms of types of data, you will also be developing the ability of communicating your results. Now, and of course, self-motivation, that goes without saying. This is a master's in data science. That will require you to structure your time. This, of course, is not a walk in the park. You will be expected to work hard. The benefits of that will be great, of course, but self-motivation will always take you very far. Now, looking more specifically at the structure of the masters. So coarsely, what we do, we divide the masters in data science. You can see at the top of the slide, there's a link here where you'll have all the information. I have distilled the key points here. So essentially, the masters in data science is subdivided in three, let's call them 3 semesters. So the first 2 are taught. The final one is a master's dissertation. So each of those parts is worth 60 credits. So it's a master's worth 180 credits. Now, going a bit more on the fine grain, what you notice is that now we have highlighted elective courses and mandatory courses. Now, first of all, thinking about what the mandatory courses are. There's only one mandatory course, which is called the Informatics Project Proposal, IPP. And of course, then the final dissertation that takes place at the end of the master's is also mandatory. Now, just spending a few seconds on the Informatics Project Proposal. What is it and why is it mandatory? So what will happen is that at the beginning of semester 2, you will select and eventually be assigned to your master's dissertation. So you will be already in contact with your future supervisor for your master's dissertation. The Informatics Project Proposal is your opportunity for learning how to structure a proposal in terms of asking a research question, building some hypothesis, determining how you're going to address that hypothesis, designing methods, thinking about the state of the art, and also addressing important questions such as data availability, ethics, thinking about timeline, thinking about contingency planning. So the Informatics Project Proposal is the course that essentially will allow you, with, of course, also some support from your future supervisor, it will allow you to build the proposal that will underpin the work you will actually do at the very end in your master's dissertation. Now, about the elective courses, it's a very flexible master's. There's quite a lot of opportunities for you to choose which courses to take so that you can tailor your own experience based on what kind of data scientist, what kind of job you would like to have in the future. The overall idea is the following. So the courses that are part of the masters are subdivided in 3 different categories: machine learning, statistics and optimization, databases and data management, and applications. So under those three labels, you'll see that there's a whole bunch of different courses that are made available to you. The only condition you have to respect when you build your curriculum is that you should essentially attend at least one course per research area. Then, of course, if you're very interested in databases, nothing stops you from heavily offset your learning towards database and data management. But we find that it's truly crucial for a well-rounded data scientist to have a background also on aspects that go beyond database and data management, or machine learning, statistics, and optimization, if that is your main interest. Now, the final thing I would like to highlight, there's also the opportunities, that's not mandatory, but that's something you can do, to attend what are called level 10 or 11 courses. So those are undergraduate courses. Now you'll see that it is indicated 0 to 20 credits. Typically, that means that you can take either none or one or perhaps two courses that are part of the year 10 and 11. Year 10 and 11 are essentially the last 2 years of undergrad. And the thing that is very interesting, I think, about this option is that you can, of course, take courses in informatics, but you can also take courses outside informatics. In fact, the only courses you cannot take are courses in the College of Medicine and Veterinary Medicine or in the Futures Institute. But if you see that there's a course you're particularly excited in psychology, because why not? You would like to be a data scientist that works in the psychology area, this is absolutely something you can do. You can explore the curriculum of the 10 and 11 levels and pick a course. Every course is subjected to some conditions. Either you should have some preliminary background, or you should have attended some prior courses already. So when you build your curriculum, you will be asked to make sure that you do have the background required to attend any of those courses. The one thing I would like to highlight among the level 10 to 11 courses is the following. So, of course, one of the key skills for a data scientist is being able to program. And it is within the expectations that you have already at least some basic experience in programming from your past education. Now, if you want to develop your programming further, and there are courses in the level 10 or 11 that you may want to consider, I'm highlighting two here. So if essentially you have less than 2 semesters of programming experience, or you do not really, or you have a job already that does not involve programming, those two courses might be of interest for you. So on the left-hand side, you have Programming Skills. That's the title of the course. And that is a course that will be useful for anyone who is interested in developing the programming skills in the area of high-performance computing. So if you want to use high-performance computing infrastructure and you want to develop software for that, either to just exploit that infrastructure or just to use it to even generate new data sometimes, that course is for you. It's provided by EPCC, that is within informatics. Or another example is, I mentioned psychology before. Well, if you're interested in natural language processing, NLP, the School of Philosophy, Psychology, and Language Sciences does offer a Python course that for beginners, that however is intentionally spun towards skills required for natural language processing. So of course, these are two examples. When you build your curriculum, of course, you're more than welcome to explore all the different opportunities that are offered by the university and tailor your own learning experience within the masters.